Yeah, welcome to my talk, quarantine edition this time, sitting at home. I altered the title slightly. It was Spatial Context is our killer application, but I think to make things a little bit more clear, I named it to Spatial Computing is our killer application. And I want to tell you a little bit why in this presentation here. So there are three key points that I want to leave you at the end of this presentation. So first is spatial computing is the future of XR. Second, XR is now architecture scale. And third, a spatial toolbox for our spatial community, something I want to share with you. So let's start with the first point. When we look at how we process data traditionally in an internet-connected world or in an industrial internet-connected world, we usually look at data objects, and the logic that processes these data. And so as such, we can get maybe the weight of a machine that the machine is lifting or the electricity that the machine is consuming. But from a computation side, we're a little bit blind about what's actually happening in the real world when atoms are moving around. And what spatial computing is at its core is adding the idea of location to every spatial computing data object. So wherever you gather data, you want to associate location to that data. And as such, for example, you know exactly not just how much weight such a robot here lifts, but you know actually exactly where it lifts that weight, and you know exactly where it consumes energy and so on. And adding that additional tool in that spatial computing data object is extremely powerful. It's a very simple thing, but it's extremely powerful. And I put this in the beginning of this presentation because you will see it is the foundation of everything I'm going to show you. So my perspective, or PTC's perspective, is from the industrial perspective. So everything that we do has to do with the industrial Internet of Things and industrial augmented reality and XR. And when you look into a factory and you see all these machines that create for example, cars, every data point, every data that is consumed here and everything that is programmed in this space requires a notion of location with the data associated. And I illustrated this in this picture here. Every one of these little nodes here is basically an idea of a location and data that is associated with it. And when we look at this as a comprehensive platform, as a system, then we can call that spatial computing. At the core of spatial computing are now very simple questions that before are very hard to answer when you write software. But from a spatial computing perspective, these questions are at the core. Where is something? Where was something over time? How did it move? So that I can use actually the historic motion as a means to program against it. How far is something away from something else? Or what is the velocity of something? So these are very simple questions, but they're really, really hard, or they were really hard to answer in the past. And now we finally have these kind of technologies that allow us to gather the location additional to the data that we want to process and start using questions like that when we write software. A very simple example with a tool that we use in our lab at PTC is we call it the Spatial Toolbox, and I will explain later more about it. And it has an edge server, and in this edge server, we now implemented these very simple questions to just give you an idea already how powerful it is to answer them directly. So I click on where is, and now any kind of object that is located in this server and in this tool, I can just click on it and it will show me the location of this object. This is a very simple example, but it shows you how powerful it already is to just answer these simple questions. I think a big point that is very confusing and all around is spatial computing is not equal to augmented reality or XR in general. The same way that a desktop interface is the best human interface for doing computing, connecting to a computer, XR is the best human interface to connect to spatial computing. But spatial computing is something that is happening all around us. It is not only happening when a human looks at it through an interface. In fact, actually, you can use that human interface to manipulate how the world is computing spatially. But in the best case, it should the world should continue to work if you're not looking at it. And when you get the idea of location associated with the data that you want to process, then you can, for example, do this super nice airflow calculations. So at any given point, the system here knows where the fan is, and it knows the actual shape of the object of the car. And through that, it can process these live animations. Or another example is that I know every detail of this robot, and I can create, through an augmented reality interface, I can create these motion pathways, and the robot will be able to drive along these motion pathways. Let me forward a little bit. Here, you see how it's driving these pathways. And so on the left side here, you see actually how traditionally you would do this with a 2D interface. It's very complicated. So it is the spatial context really that allows augmented reality to be such a brilliant interface for anything spatial computing. Another example is, for example, you have allergies and you can perform a spatial search on spatial information associated with objects in a grocery store, and it can immediately show you what you have allergies for and what not. So augmented reality, or any other kind of reality, and it's called XR, is a perfect user interface to visualize spatial computing for us humans. And any advancement in augmented reality will also bring advancement for us humans to better interact with spatial computing. And so I want to go into these advancements a little bit more. So traditionally, we look at objects when we use augmented reality. We track objects around us and associate data with them. But what is really interesting is that now we actually can look into architecture scale. Now we're not bound to individual objects, individual experiences anymore. We now actually can go into the spaces around us. And one of these works is here at PTC in the Voyer engine team. And what they are able to do now is to scan massively big spaces and fly around in these spaces. And they're being able to localize yourself in any of these spaces with the Voyer engine. And so in some environment like that, you can, for example, build route plannings now. You can tell this little drone here, hey, show me the kitchen. And the system will automatically show you the pathway to the kitchen. Again, this is a question of where is something and how do I get there? And you can ask, how far is it away? All of this is enabled by a new tool that in that Voyer engine is called area targets. And area targets allow you now to localize devices relative to spaces around you and not just see objects anymore. So this is very powerful. And it is so powerful because the Voyer engine is a key component, or the area targets is a key component for spatial computing to really expand our user interfaces for this kind of technology into the spaces around us. And Engine is also the world's most widely deployed AR. So This is really, really powerful stuff and available to every one of you guys. And recently, we announced and published a new tool in the Voyer product family, and that tool is called Voyer Spatial Toolbox. And we have open sourced this tool for everyone to explore and experiment with it. And I want to invite you to join this community and experiment with it as well. So find us at the spatialtoolbox.voyer.com webpage. And this toolbox is really a foundation to explore all of these spatial computing questions and provide a user interface for humans for that. At the core of this spatial toolbox is the idea of that spatial computing data object, and we call it a node. And every one of these nodes has location associated with them, has data storage, and the ability to process logic. And everything in the spatial toolbox is built up on top of this data object. It is fully compatible with the entire Voyer engine tracking capabilities, and it has the notion of trackable objects, things that in the world that you want to interact with. It has world objects, entire spaces that you can populate with data and process against it. And it has world anchors that are basically a mixture between objects, trackable objects, and world objects, so you can reference them against the world. This toolbox is massively extensible. It has an add-on structure built in that allows you to build tools that you can place in this toolbox, spatial tools. It has the ability to add hardware interfaces, so for any kind of hardware you want, and I'm going to show some of that. It has nodes that allow nodes and logic blocks that allow you to change the logic of the system, and some feature scripts that allow you to change the entire appearance of this tool. And so we have a couple of like core add-ons that allow you to connect to industrial machines where software is called Capware, but also robotic interfaces for MER robots or something new that's called the Legobot Boost robot, a new interface we just built. And so here I want to show you that toolbox in a nutshell. So there's this little button on the side, and it opens a selection of tools that you can use to understand the world and to control the world. And so here's a little example. It's a slider and a graph, and it has spatial programming capabilities. So you can just create a link between the one and the other. And that is a very simple program, and it already shows you some simple capabilities. You can move these things around, you can scale them, and you can even define how far away things are visible when you approach them. So this allows you to really nicely choreograph the user interface for spatial computing. This toolbox is fundamentally grounded in the real world, and as such, I can just step up to such an industrial machine here, and it unveils how this machine was programmed. And that is not just a program, actually. This is actually, or that's not a visualization of the program. That is actually how this machine is programmed. So, for example, if I interrupt this program, as expected, the machine stops. I can reestablish this link, and the machine continues. So it's a very simple interface. And if I want to make changes to the software, I can click on these square nodes, and a little programming interface opens up. And with logic blocks, I'm able to change the program. In this case here, I want to invert it. And you see how now I have made adjustments to the system. So all of this is open sourced, and you're available to experiment with this and build your own augmented reality interfaces for spatial computing. So here we have a second table, and you see already some spatial tools that allow me to set limits for how much should be put into this bin. And because it's an augmented reality interface, I can just easily drag and drop a line from A to B and make these two systems work together. So as such, this is in a nutshell what is the Spatial Toolbox and what it's capable of doing. But this is really just the core functionality, and through those add-ons that this toolbox has, it is massively extensible. It has a wonderful visual design that we work together with a fictional user interface designer, Andrea Braga. And this design is a high contrast functional user design. And these interfaces work under every circumstances, in a dark or in a bright environment. It really works well against every kind of augmented reality environment that you would want to drop them on. Here's another kind of interface for robotics. Yeah, it's a very beautiful. The interesting thing is we published this toolbox in April, or we had the plan to publish it in April, and then all of us started to work from home, and the same like this quarantine edition here of this talk, we're sitting in front of a video conferencing tool, and we're not in factories, and we're not in innovation labs, and we're not having the tools around us that we usually would work with professionally. So what we started to do, because this toolbox is so extensible, we started to build hardware interfaces, add-ons for things that we have around us at this point in time. So there is a basic add-on in this toolbox, and you can find it all on that webpage, that allows you to connect, for example, to your Philips Hue lighting system. It allows you to connect to all the Lego connected devices like the Legobot Boost, or even Arduino boards if you have some DIY projects. And we are extending even more devices that can be used with the Spatial Toolbox. And I'm happy to look forward to discuss with you what kind of interfaces we should add so we can make more things available while we're all at home. And I want to show you some of the demos that we built with this add-ons. So the first one is, we have built a programming tool for this little robot here, the Legobot Boost robot. So Anna, a researcher in my team, she is building this user interface at home right now. And so she can put these pathways on the floor and add a a button. And because everything in here is programmable and interconnected with these nodes, she can just connect that button to the starting point, and now you see how this robot is driving along that line. And I just forward a little bit. It takes a moment. So this is public. You can try this out at home. Just go to that webpage, download the Edge server, find the Spatial Toolbox in the App Store, and start playing with your Legos at home right now. Another example from our extended community is basically using the area targets to track your entire home and then connect your Philips Hue lights with the system. So you have augmented reality interfaces now that you can precisely control the lights around you in your home. Okay, so this is the Spatial Toolbox. That's what we enable. That's where we further explore this and really make this a foundation for spatial computing and building interfaces for it. And I want to give you a little sneak peek into our laboratory. So usually I'm sitting in this space here. It's called the PTC Reality Lab. By the way, we're hiring research positions right now. So if you feel the calling working with us, send us an email, contact us. And so usually we are in this space and we're exploring spatial computing in this space. And there are two little experiments that I want to show you. The first experiment is there are no boundaries anymore. We connect the physical and the digital, and we connect the desktop with augmented reality And in such a world, why not building an HMI on a screen and then just taking it out of the screen and putting it into the real world? Because we want to make data flowing seamlessly between every kind of reality, the physical reality, the virtual reality, augmented reality. That for me is true XR. And the other thing that I want to show you is that user interfaces don't have to come in the form of a head-mounted interface or in the form of a phone. We're expanding massively into the space around us. So here you see something called a crown truth, a recording of our laboratory. And in this laboratory, we installed a couple of Azure Kinect cameras. And these Kinect cameras are calibrated into the space. And as such, it allows me to actually now follow humans through the space and make them part of a spatial computing experience as well. And so the same space that you can see through a phone, that you can see through augmented reality at the location, I now can fly around in virtual reality or in virtual augmented reality. And the Spatial Toolbox is deeply intertwined into the system. So here you see a little demo. You see the same interface that you saw before through a phone. You're now seeing through a bird's eye perspective, co-located virtually into that scene. All of this is working in a web browser. So you can sit on the other side of the world and co-locate yourself with Ben, who has this phone here in his hand and currently is programming and operating this machine. So I can just co-locate myself and be there. And I think right now in this time, being there is a very valuable good. And being there in such a way that you can co-locate and fly into a factory is very potent, very powerful. So with that, I want to end this presentation. And we've talked about spatial computing is the future for XR. I want to encourage you, join our spatial computing community, spatialtoolbox.voyer.com. Experiment with this tool, make something with it, join this community, add your own ideas, collaborate with us. We really want to work with you together. This tool is open source. It is under MPL 2.0. You can really use that as a foundation for your own work. And last but not least, join our team. We are looking for a candidate who helps us to make these experiences stronger, to research the next level of spatial computing, and to really make a dent in this technology. PTC is the most wonderful place to experiment with these things, and I'm looking forward to talk to you. Thank you for your time.
Valentin, what a great product the Spatial Toolbox is.
Hello.
Congrats.
Thank you.
Unfortunately, the presentation was way over the quota, so we'll need to move all the questions to be answered on the video stream chat box. Thank you again, Valentin, for a great presentation, and congrats for a great product you have created. And now we'll need to move forward and